Cool. Okay. I'm hoping that most people here have at least heard of Mongo, because I know it got touched on in the previous talk that we saw. If anyone doesn't know what it is, it's something Sitecore introduced a couple of years ago, and it's their way of storing huge amounts of data. It's a proprietary database system. It's free to use. It's pretty much free to set up. What hopefully you'll get from this is what to do if you host it yourself and how to make it run fast. I'm Nick Hills. I work for a company called True Clarity. We're based over in Bristol, and we've got some guys working here in London as well. We do a lot of work for EasyJet, so doing some pretty cool stuff for them, which is going out, well, as fast as we can code it, really. So, yeah, if you use EasyJet on your phone today, you might actually see some new, some quite cool stuff that's running on Sitecore. Mongo's been in the press a little bit recently, maybe for reasons that you don't particularly want to follow. So when you install it, in the old versions, there wasn't a password and there wasn't particularly a tough username to guess. Hence, this sort of thing. What sort of rubs salt in the wounds, I think, is hackers have been coming along and leaving these like ransom notes, and then another hacker's come and left a ransom note for the first one. So that sort of cycle and spiral of things isn't great PR for them. It doesn't have to be that way. If you've got common sense and you can configure your firewalls and security groups, or however you choose to do it, and passwords, you shouldn't have this problem. So, but that's not really what this talk is about. This is more about how you can scale up, Mongo. If you're using it as a service, then this probably doesn't really apply, because ultimately someone else is dealing with that kind of problem for you. I don't really know what you'd call Mongo as a service or database as a service. I don't know, you make that. But essentially, if you're hosting it yourself, this hopefully will help you get to the bottom of your problems. So Sitecore introduced Mongo into a couple of places. One is up here, I can't really see it too well, sorry, but that's where it collects all this data about users. So people come and visit your site, and their interactions get stored in Mongo, page events that they trigger get stored in Mongo, any goals, all that sort of thing. So yeah, you've got XDB that lives up here. Every time that someone requests a page, it's not actually necessarily going to talk directly into Mongo. It uses the session provider that's in place to buffer that, and that's in this diagram up here. And you've got a choice. You can either use Mongo for that, you can use SQL, and now you can use Redis, and you've got various options. If you want to have a look at kind of how this is glued together and you don't know much about it, then yeah, that link there will give you some information there. So you install Mongo, you get your site up and running, this is brilliant, you get all this personalized data, and then suddenly stuff starts to slow down. You're finding problems with performance. And often those things can be pretty tricky to get to the bottom of. How do you check where in this big architecture of stuff are things going wrong? I mean, if you think, in this diagram we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of this puzzle, and ultimately the site's running slow. It doesn't necessarily point directly to where the problem is. So let's have a look at basically how we can get this optimal performance. If you're doing load testing or anything like that, you will probably see lots and lots of these sorts of things. You'll see graphs that hopefully remain flat. That tends to be a good thing. If they do this towards the end, you're starting to run into problems. So when we did these load tests, this was back at March time, I think, last year, we managed to get out of the system we were testing a pretty good rate of input and output. So TPS, RPS, it's all kind of the same kind of thing. How many requests can you serve up at the same time? And in this setup, I think we were hitting about 300 TPS, and the response times for the requests we were making were still coming back under 0.2 seconds. So these numbers may mean such different things depending on how you host it, depending on what you're trying to get out of it, but hopefully this proves it can be done. If you need to get up to that number of transactions that are going through that quickly, then there you go, it's doable. We kind of got a bit stuck there. We were doing this, and we were running lots of load tests. We cranked the boxes up to be a huge amount of RAM, huge amount of CPU, huge amount of bill, obviously. and we weren't really getting much more performance. So we spoke to the guys at Sitecore, and at the same time they were doing something similar themselves. They were trying to prove this concept of how much throughput you could get and the sort of performance you'd see from Mongo. So they pointed at this white paper. I'd suggest having a look at that. If you're trying to achieve and solve these same sorts of problems, that's a good start point for seeing how they set things up and what their kind of deployment architecture looks like and infrastructure, so you can see exactly how they chose to go and do this sort of thing. So we did, like I said, we tried a slightly different approach at first. We basically turned it up. We just went in AWS, found the biggest, well, not the biggest box, because that's ridiculous, but we found a huge instance, tried that, and it just wasn't, we weren't getting any more throughput. We were stuck at saying, well, the response times were basically churning away and just were crap. So yeah, Arnie wasn't quite right this time around. What we found, as we spent a bit more time and talking with the Sitecore guys, is that there's a few things that we need to do. We need to get big, fast disks in there. In the cloud, this is quite an easy problem to solve. You have this concept of what they refer to as IOPS, and we'll just touch on kind of what that is. It's all about the IOPS. What does that actually mean? What are IOPS? So yeah, if you Google it, that's what you find out. Input and output operations a second. It's kind of how fast you can interact with the disk. And certain operations that you're dealing with in the sort of Mongo and Sitecore world, this kind of thing is absolutely crucial. Just if you have a look at, how Azure and AWS handle this. Azure's got premium storage, so this is your fast I/O or IOP-based disks. AWS has something similar. From what we found, I think with AWS, you get really good control over exactly your thresholds you want to adhere to or sort of sit within. The cost obviously will go up the more IOPS you reserve, but yeah, you can get super fast performance out of it if you do. So then, it's all well and good having these really good disks, but actually how do you make use of them? How do you harness the power that they've got? There's a few quite simple settings you can apply in Mongo. The first of which that I'd recommend doing is this, setting up directory per database. Now this is quite a simple thing. All it does is every single database and collection that you're dealing with will get put on a separate folder. So in the Linux world, you can back that with its own disk. So that's where the high IOPS starts to really come into play. In Windows, it's slightly different, but you could set up kind of linked directories to achieve the same thing. Next up, Wide Tiger. We found we got much better performance when we used that rather than mmap, purely around the locking we were seeing on the collections and at the sort of document level rather than at the whole collection. And if you really need to push it, you've always got sharding as an option. So you could look to try and split the data out across many Mongo collections essentially, rather than just having it in one single point. If you're using Linux, then yeah, you can format the disks in different ways. XFS will get you much better performance. And really, once you've got this in place, I think what helped us so much was being able to see exactly what was going on. So for the tests we ran, we were using New Relic. As part of that, you can see for every single disk that you've got in place. So here you can see we spliced out, I think we had about 3 or 4, so one disk specifically for the analytics collection. And from this, we could actually see the exact IOPS we needed and whether we were hitting bottlenecks and all that kind of thing. So from this, I think we kind of overestimated exactly what we needed for this test. There we go. Hopefully that was within the time, and if anyone's got any questions, then shout. Really, things to think about, I guess. Yeah, find where the problems are. C, it's going to be disk, it's going to be network, it might be RAM. You need to isolate these things to be able to sort of track down the problems. And yeah, the way we've solved it might not actually be the right thing for everyone, but we got the throughput we needed. So, I'll leave it at that. Yeah, there you go.
What about sharding?
Sharding, yeah. Split it up in it.
Ask the black
the visitors. So how many contacts? Why MongoDB was so stretched?
How many what, sorry?
Visitors, contacts.
Well, if we're getting 300 transactions a second, that was based off 300 new users a second, because that was what was getting flushed into XDB. So you could extrapolate that out to work out the number of visitors. In terms of the amount of load we've got, I'm not sure off the top of my head. The targets we were trying to hit were to hit 300 TPS. So the fact we were achieving that, you could interpolate out to work out the numbers of visitors.
Just